Hello students, welcome back to e-learning edu. So in today's class we'll be learning about the Born Haber cycle in a very simplified manner. See here, in this process of Born Haber cycle, first of all we need to know the term lattice enthalpy. So lattice enthalpy means it is energy which is needed either to gain the electron or to lose the electron. So here, for example, if there is a formation of a molecule, say NaCl, so when there is NaCl bond formation, the Na plus will be combining to form the Cl minus ion. So here the energy which is needed to form the bond of this NaCl, we can refer it to as the lattice enthalpy. So that is what is meant by lattice enthalpy. So here the lattice enthalpy of this molecule can be calculated by using the simple method which is known as the Born Haber cycle. The experimentally we can calculate the lattice enthalpy of this molecule by the Born Haber cycle. So here in this first of all you need to know the various process happening. So here at first the reactant is getting converted to the gaseous state, and from this gaseous state the reactant is getting converted into the ions, and these ions, whatever the ions are formed, these ions will be combining together to form the ionic compound. See here, this is one example. Na, first is the formation of Na plus from the solid Na and formation of Cl minus, and again they both will be combining together to form the NaCl. Now let us see the steps which is happening here. So at first in this Born Haber cycles, here in this Born Haber cycle, the first step is Na which is present in the solid state is getting converted to the Na gaseous state. So here from the solid state, since it is getting converted to the gaseous state, the process is known as sublimation. So the lattice enthalpy or the enthalpy of sublimation of this is found to be plus 108.5 kilojoule per mole, and again in the next process this gaseous Na will be getting converted to the Na plus, and when this Na is getting converted to Na plus, obviously there will be loss of one electron. So and since there is a formation of ion, this enthalpy is accompanied by the ionization enthalpy. So the ionization enthalpy of this Na, the getting converted to from Na to Na plus, is found to be plus 496 kilojoule per mole. So and we are done with the first process, that is a solid or the reactant. So here our reactant is sodium. So the sodium is getting converted to Na, that is a gaseous state. The first step, half of the first step is cleared here, and again next step is the gaseous ion is getting converted to the gaseous material is getting converted to the ionic compound or the ions. Here this Na is present in the gaseous form, which is getting converted to the ionic form, and in the next process so we have got the Na is getting converted to Na plus. So the first half is completed, and next the other product is Cl. So the raw material for Cl is present in the form of half Cl2. So here in this process half Cl2 which is present in the gaseous state is getting converted to the Cl, which again in the gaseous state, and the enthalpy change is enthalpy of dissociation. So here the bond gets dissociated, so the enthalpy is known as the enthalpy of dissociation, which is found to be plus 121.5 kilojoule per mole. And in the next process the gaseous chlorine needs to be gets converted to the ionic Cl. So when this chlorine gets converted to Cl minus, obviously it will be accepting this one electron which is lost by Na. So it will be Cl will be gaining one electron. So Cl which is present in the gaseous state will be gaining one electron, so that to form Cl minus. See here it gains electron to form Cl minus, and the enthalpy change is known as the electron gain enthalpy, which is found to be minus 348.6 kilojoule per mole. So since it is gaining the electron, that the enthalpy accompanied will be having the negative charge, because the process is exothermic. And so we have got the two ionic forms, right? That is Na is getting converted to Na plus, and Cl is getting converted to the Cl minus. Now these both will be cutting or these both will be combining with each other. So Na will be combining with, that is Na plus will be combining with the Cl minus in order to form the solid NaCl. So see the steps here. So the reactants, our reactant was Na, which was in the solid state getting converted to the gaseous. So Na is getting converted to Na gaseous, and Cl half Cl is getting converted to the gaseous Cl, and after that the gaseous elements are getting converted to the ions. So gaseous ions, in the sense Na, which is present in the gaseous state, is getting converted to Na plus, and half Cl2, which is the Cl which is in the gaseous state, it is getting converted to the Cl minus ion. So the second step we are completed with the second step, and in the next step these both ions will be combining together, right? So here Na plus will be combining with the Cl minus to form the ionic compound, that is the NaCl. That is a final step, and after that we'll be just combining the raw material. So the raw material of Na is solid Na, will be combining with the raw material of the Cl, that is half Cl2 gaseous state, to form the NaCl, and the enthalpy of formation was found to be 411.2 kilojoule per mole. So this is what you have to write in the Born Haber cycle. So when it is asked for exam, you have to draw all these equations, and after that draw this Born Haber cycle. You have to represent it diagrammatically. It is very easy and simple. See here, the solid Na is getting converted to the gaseous state, right? And the process, getting converted from the solid to gaseous state, the process is known as sublimation, and this sodium is getting converted to the Na plus, right? So this process is known as the ionization. So here the process is ionization. And now about Cl, half Cl2 is getting converted to Cl, and the process is accompanied by dissociation. The bond is breaking. So here bond dissociation enthalpy, this chlorine is getting converted to Cl minus gas, and here the process is the electron gain enthalpy, and this Cl will be getting that is Na plus will be combining with the Cl minus to form the NaCl, and whatever the energy which is used to form the bond, it is known as the lattice enthalpy. And after that we can calculate this lattice enthalpy of the molecule. So here this Born Haber cycle is used to calculate the lattice enthalpy of these molecules. So here we can calculate this by applying all the other values, that is lattice enthalpy will be equal to sum of all the other value. So we'll be getting it as 788 kilojoule per mole. So I hope you are clear with this Born Haber cycle and the lattice enthalpy, which is very simple to study and very important in the examination point of view. So hope you are clear with this, and do subscribe, recommend to your friends, and like my channel. Thank you.